Hey everybody. Um, Today I want to go over a problem like we did Monday, but all in one step. Well, there's multiple steps, but all together. So this comes from page 15-11 on your guided notes. We have the equation NO2 plus CO yields NO plus CO2. So what we want to do is first determine the reaction orders and then figure out the rate constant, which we didn't do Monday, but we're doing Tuesday, and then write the full rate equation. So like Monday, what we do to figure out the reaction orders is we take a ratio between the rates of the experiments where one of the concentrations is constant. So not sure if you can see this chart, but this is on page 5-11 above the example, below the equation. But we can write the rate log right now as the rate constant times the concentration of NO2 raised to the reaction order times the concentration of CO raised to that reaction order. So what we're going to do is take the experiment data and take a ratio. So what I did first was look for constant carbon monoxide concentration. And so we get that in experiments 2 and 1 and 3, but let's just focus on easy, just take the first two data points, so 2 and 1. So what we can do is say we want to write the rate equation for rate 2 and rate 1. So that would be K times the concentration of NO2 raised to the reaction order of rate 2, of experiment 2, times the concentration of carbon monoxide raised to the reaction order for experiment 2, over K times the concentration of NO2 for the first experiment raised to the reaction order, times the concentration of carbon monoxide for experiment 1 raised to its reaction order. So here we have constant carbon monoxide. Therefore, we have the concentration of carbon monoxide cancel out. The K's are constant, so that would cancel out. So we are left with rate of experiment 2 over rate of experiment 1 equals the NO2 raised to the reaction order of experiment 2 over the concentration of NO2 raised to the reaction order of experiment 1. That proportion is going to be the rate or the rate of experiment 2 over the rate of experiment 1. So that's the 6.8 times 10 to the negative 8 over 3.4 times 10 to the negative 8. And then that's going to equal the concentrations raised to the reaction order. Therefore, we've got 0.700 times 10 to the negative 3 over 0.350 times 10 to the negative 3. The 10 to the negative 3's cancel out, or sorry, not negative 3, negative 4. And the 10 to the negative 8's cancel out. So we are left with 6.8 over 3.4 is equal to, and this is all raised to the power of m, is equal to 0.700 over 0.350 raised to the power of m to the reaction order. Therefore, we get 2 equals 2 to the m. So m equals 1. So we know that the rate is going to equal the rate constant times the concentration of NO2 raised to the first power times the concentration of CO raised to a certain power. So to determine the experiment for the reaction order for the carbon monoxide, we're going to look for something, an experiment that has the NO2 constant. And we have experiment 5 and experiment 4 that has NO2 constant. So we are going to go ahead and do the same thing that we did for the NO2, but now for the CO. So now we have rate of 5 over rate 4, and that is going to equal the constant times the NO2 concentration raised to the first for experiment 5 times the concentration of carbon monoxide for experiment 5 raised to the reaction order over the constant times the concentration of NO2 for the fourth experiment raised to the first, because we determined that the reaction order is 1 for NO2, times the concentration of CO for the fourth experiment raised to the n. The K's are constant, so they cancel out. The NO2 concentration is constant, so the NO2's cancel out. Therefore, we have rate 5 over rate 4 equal to the concentration of carbon monoxide in experiment 5 raised to the n over the concentration of carbon monoxide in experiment 4 raised to the n. So plugging in our numbers, we get 1.53 times 10 to the negative third. That's the concentration. Divided by 1.02 times 10 to the negative third is going to equal the rates, which is 10.2 times 10 to the negative 8 over 6.8 times 10 to the negative 8. The 10 to the negative 8's cancel, the 10 to the negative thirds cancel. Therefore, we get 1.53 divided by 1.02 is going to equal 10.2 divided by 6.8. And that's going to equal 1 point, and this is raised to the n, I'm sorry. 1.5 is equal to 1.5 to the n. Therefore, n equals 1. So then our rate law is the rate is equal to the rate constant times the concentration of NO2 raised to the first times the concentration of CO raised to the first. So this is nothing different than what we did on Monday. All you have to do is take the experimental data, make a ratio of one of the rates, and make sure that one of your concentrations is constant, get your equality, and then figure out, okay, if I take this and raise it to some power, I get my ratio. So thankfully, this was easy. If we got 4 for if we said that this was 4 equals 2 to the m, well, 2 squared is 4. So m, if this was 4, m would be 2. But that was not the case. It was just 2 equals 2 to the m. So m was 1, because anything raised to the first power is itself. So this is no different than what we've done on Monday. Now, what we had done on Tuesday, we're still on A. We want to figure out what K is. That's real easy. It's just algebra and plug and chug. We know that the rate is going to equal the rate constant times the concentration of NO2 to the first times the concentration of CO to the first. Do algebra to solve for K, and we get K is going to equal the rate over the concentration of NO2 to the first times concentration of CO to the first. And now all we have to do is just plug in numbers from one of our experiments that we want to try. So might as well plug in from the first equation. So we would have K equals rate 1 over the concentration of NO2 for experiment 1 to the first times the concentration of CO for experiment 1 to the first. Therefore, K is going to equal 3.4 times 10 to the negative 8 over 0.350 times 10 to the negative 4th times 5.10 times 10 to the negative 1st, and both to the 1st power, but that's not going to change anything. So K, when you work that out into your calculator, is 1.9. And you have that little chart on your paper on page 5-11 that tells you the units. Overall reaction order is second. So it is liters per mole hours. Therefore, the rate law is going to be 1.9 times the concentration of NO2 to the first times the concentration of CO to the first. Now the rest is super easy. B is asking you, using the rate equation and constant determined above, determine the initial rate of the reaction when the concentration of carbon monoxide is 3.8 times 10 to the negative fourth, and NO2 is 0.65 times 10 to the negative fourth. Very easy. That is a straight up plug and chug problem. Once you've figured out the reaction order for each reactant and what the rate constant is, all you have to do is a plug and chug and get the rate of the equation when the concentration, when you're given the concentrations. So this is B. So the rate at any time is going to be 1.9, and we're given the concentrations. So that's going to be 0.65 times 10 to the negative fourth to the first times 3.8 times 10 to the negative fourth to the first. And all you have to do is plug it into your calculator. The rate is going to equal 4.7 times 10 to the negative 8 mole per liter hour. So that covers the example on page, like I said, 5-11. When we get the problem set for the rate unit, we will do a problem like this. I just have to find the problems that I want to do. But thank you very much for learning with me today. I enjoyed learning with you.